Hey everybody, it's Mr. Stoltenberg again, coming to you with yet another video over the solutions unit. This will be the last calculation that we're going to learn how to do today, and potentially the last video for the solutions unit, depending on which class you're in. But here we go. Last calculation, last thing we're going to learn how to do is dilution problem. Before we get into this, think about the word dilute. It's a word that you're probably relatively familiar with, and probably vaguely understand what it means to dilute something. So if I tell you to dilute something, what do you think that would entail? What might you be doing? Some of y'all are probably thinking about watering down, adding water, and that's pretty much what a dilution is. It's an it's adding solvent. In our case, most of the time the solvent's water. So it's taking a solution that's of a certain concentration, of a strong concentration, and turning it into a solution of a lesser concentration. So going from a solution with a high molarity to a solution that's of a lower molarity, and we do this by adding solvent. This is one of the most common things that I do when I'm preparing for y'all's labs. When we order chemicals from chemical production companies, they come concentrated. If they're in solution form, they come concentrated. That means that they don't have to ship, large volumes. They can ship small volumes at super concentrated levels, and then I am responsible for diluting them. We use acids quite often in our labs, and if I were to give you concentrated acid to start these labs, well, that would be one, extremely dangerous, and two, highly irresponsible. So it's my job. Part of my job is to make sure that those chemicals are safe enough for y'all to handle, and the way I do that is by diluting. So doing dilutions is something that I do quite often. So here in our example problem, it says we need 800 milliliters of 0.25 molar HCl solution. The only available HCl is concentrated, meaning it's 12 molar. Generally speaking, concentrated can mean there's not a specific molarity that it means. It usually just means it's 12 molar or higher. Giving you 12 molar acid is not an option. That stuff is super strong, and it makes me nervous to handle it. But I have to be able to do this kind of dilution. So how can I do this? Actually, the math behind it is really, really simple. We use this simple equation. M1 V1 is equal to M2 V2, where M1 represents the molarity of the concentrated solution, V1 represents the volume of that concentrated solution, molarity M2 represents the dilute molarity, and V2 represents the volume of the dilute solution. So if you're doing this in a real world practical sense, which one of these four variables do you think you're going to be normally solving for? I'll let you think about it. Look at the question in number 3 up here. What makes the most practical sense? What are we going to be solving for most often in a practical use? Well, let's think about it. Will we ever need to solve for molarity 1 in a real world situation? No, we should know that. We should know what the concentrated solution's molarity is. It should be on the bottle. If it's not, then we have an issue, because that's a solution of an unknown concentration. It could be pretty dangerous. Will we ever be solving for the molarity of the dilute solution? Again, this is something in a real world practical sense. No, you should know. In this particular question, I know that I want 0.25 molar solutions. Okay, what about the volume of dilute solution? Again, this is another thing that I should know. If I'm preparing this for a class, then I know the concentration that I want, and I know the approximate volume that I want. So ultimately, in the end, if you're doing this for a lab, or you're in college and preparing solutions, it's really the volume of the concentrated solution that you're probably going to be solving for the most often. Um, you need to know how much of that concentrated solution you need to ultimately make the dilute solution that you're looking for. Now, in our practice problems, that you're going to be solving for all four of these, but really solving for these doesn't make a whole lot of sense in the real world because you should know those. Solving for the initial concentration is another thing that you should know. Hopefully you do know. So really in the real world, it's that volume of that concentrated solution that you would be solving for. And it's a math problem that I do all the time. All right, so let's look at this question that we have. So we know the initial molarity, the concentrated molarity is 12. We know we want 0.25 molar, and we know we want 800 milliliters. So the question is, how much of that 12 molar solution do we need? So we set it up just like the equation is written, and it's pretty simple. 12 times your initial volume, which is your unknown, is equal to 0.25 times 800. Notice I didn't change it. It's in milliliters. Is it okay to be in milliliters here? We know molarity has to be in volume, right? Molarity has to be in volume. But is it okay for this to stay in milliliters? It is okay, as long as you understand that if this is in milliliters, then guess what your answer will be in? That's right, it will also be in milliliters. So we do the math here, right? And we get 16.67 milliliters. So what does that mean? We need 16.67 milliliters of 12 molar acid to make this. Well, 16.67 milliliters is not equivalent to 800, right? So where's the rest of this volume coming from? Okay, remember, this problem is called a dilution. We're going to dilute it. So we're going to take 16.67 milliliters of the concentrated solution, and then we're going to dilute it with water till we get the desired volume that we're looking for. So in this case, we have 16.7 milliliters. That's the amount of concentrated acid that we need, which means that we would have to add 783 milliliters of a solution of water to get the 800 milliliters that we need. So when we're preparing this solution, the 800 milliliters of 0.25 molar, 16.67 milliliters of that solution will be the concentrated acid, and the rest, 783.83 milliliters of that solution, will be water. And that's how we get our diluted solution. Just a side note here, you won't be doing this in my class ever, but you might find yourself doing this in a lab in college at some point. There's a little rhyme here that you need to know so that you don't have something blow up in your face. So when you're dealing with concentrated acids and you're diluting them, there's a right way and then there's a very wrong way to do this. And the way I've remembered it since high school is a very simple rhyme. And I just remember there was a poster in my high school chemistry teacher's classroom with an otter on it, and it said, "Do what you oughter, add acid to water." So what that's telling you is if you're going to dilute this solution, you need to add the acid to the water, not the water to the acid. It has to do with the fact that the acid will quickly deprotonate water, and if you do it one direction instead of the other, it could potentially, the reaction is so volatile, it could start sputtering and like basically blow up in your face. I mean, not like fireball, but shoot water and acid up, and you don't want that. You don't want to have acid shooting up into your face. That's not a good look. So do what you oughter, add acid to water. So if I was preparing this solution, which I've done something like this many times, I would take probably, I'd figure out that I need about 783 milliliters of that water, and I would take probably add about 750 milliliters, and then I would add the acid, and then I would fill the rest up to whatever volume I need. Um, at that point, it'd be dilute enough that it wouldn't be an issue. So do what you oughter, add acid to water. Um, just a little side note there. All right, so let's look at some practice problems. Here are your practice problems in your notes. I'm going to switch over the desktop camera, and we'll work these out together. All right, let me switch over. All right, dilutions. So, real question is, how do you know you're dealing with a dilution problem? How will you know that it's an M1, V1, M2, V2 problem? Well, oftentimes the word dilute or dilution will be used in the question. Sometimes it won't. Just look for words where it's basically saying, how would you prepare? How would you make? Those are, that's kind of telling you it's a dilution problem. So we're going to use M1, V1, M2, V2 on all these. So I'm going to make sure I know that M1, V1 equal to M2, V2. Concentrated molarity times that volume is equal to the diluted molarity times the diluted volume. All right, so it says, how would you prepare 485 milliliters of a 0.39 molar solution when a 1.0 molar solution is all you can find? All right, so, well, this is more concentrated, so I'm going to call this M1. This is less concentrated, so I'm going to call this M2. So this is my initial molarity. This is my final molarity. So which volume is this? Is this V1 or V2? This is V2. It's the volume that's associated with this molarity. So we have our final molarity. We have the final volume we want. We have the initial molarity, so that means we must be solving for the initial volume. How much of this 1 molar solution do we need to make 485 milliliters of 0.39 molar? So M1, V1. So M1, 1, V1, X. M2, V2, 0.39 times 485. Again, it's okay that it's in milliliters, just means my final answer will be in milliliters. Well, this is pretty simple, 1x over here. So all I have to really do is multiply. See, 0.39 times 485. You get 189.15. Technically, I'm supposed to round this to 2 sig figs. That seems probably too much, but that's what I'll have to do. So 189.15 rounds to 190 milliliters. There you go. Really simple. So essentially what we're saying is, if I want to prepare 485 milliliters of a solution that's at that concentration, starting with a solution that's at this concentration, then I'll need 190 milliliters of it, and then the rest of that would be water. I would add water till I got to 485 milliliters, and that should give me a solution that is 0.39 molar. All right, let's go on to the next one. So it says, if 300 milliliters of a 0.25 molar solution of nitric acid is added to 500 milliliters water, what is the molarity of the dilute solution? So this time we're solving for the M2. So we have 300 milliliters to start with, so that's V1. of a 2.5 molar solution, so that's M1. So there's our ones. It's added to 500 milliliters of water. What is the molarity of the diluted solution? So we're solving for M2. So what's our V2? This is where you got to make sure you're reading these questions rather carefully. The math here, the calculations itself is not very difficult. So the only way I can make these problems more difficult is by kind of wording them a little tricky. So a lot of people might tell me that the V2 is 500 milliliters, but you have to pay attention to words like this. It's added to. So V2 is not 500 milliliters, it's 500 milliliters plus 300 milliliters. So V2 is actually 800 milliliters. So pay attention to those that wording. It definitely would change your answer here. But now let's just plug in the variables and solve. So M1 is 2.5, V1 is 300, M2 is our unknown, V2 is 800. So 300 times 2.5, what's that, 750? 800x over here. Divide both sides by 800. And that will give us our final molarity, our diluted molarity. 750 divided by 800. Let's see, 2 sig fig, so we'll say 0.94 molar. Nitric acid is HNO3. There you go. Easy. Easy, easy. All right. See if you can solve this one. Go ahead and pause it, work it out, and see if you can't figure it out, and then we'll come back and we'll work it out together. All right, let's see what we got. It says prepare a dilute solution. So 0.5 molar, that's my dilute solution. So this means that's M2. Nitric acid from 15 molar stock solution. Oh, that's really concentrated. That's our M1. That would make me nervous handling that. You'll need 600 milliliters of the dilute solution. So we need 600 milliliters of this. So this must be V2. All right, so what does that mean we must be solving for here? We're solving for V1. So M1, 15 times V1. How much of that 15 molar solution do we need? That's what we're solving for. We want a solution that's now 0.5 molar, and we need 600 milliliters of it. So we have 15x here. Half of 600 is 300. So 300 divided by 15 will give us the quantity of the dilute or of the concentrated solution that we need. So 300 divided by 15, what's that? 20? I think it's 20. Yep. 20. And since our initial volume was in milliliters, our final volume will also, or since the given volume was in milliliters, our answer will also be in milliliters. So if I was preparing this solution, 20 milliliters of this solution would be 15 molar, would be the concentrated solution, and then the rest would be water. So 20 milliliters would be the 15 molar solution, and then 580 milliliters would be water. All right, last question. Again, go ahead and pause it, see if you can work it out, and then we'll work it out together. All right, it says, how would you prepare 500 milliliters of a 0.25 molar solution of NaCl from a 3 molar stock solution? So 3 molar, that's the more concentrated, so that's M1. So 0.25, that must be M2. So those are concentrated molarity, or dilute molarity. We want 500 milliliters of this, so this must be V2. So again, we're solving for V1. Notice this question says, how would you prepare? Well, so in the end, when we're done, the solving for X, that's not our final answer. So let's just keep that in mind. So M1 is 3 molar. V1 is what we're solving for. We're trying to figure out how much of that 3 molar solution we need. Our dilute concentration is 0.25, and we want 500 milliliters of it. So of course this is 3x here. 0.25 of 500. What's that? 125? Yep. 125 divided by 3. And it's 41.6666666. So we'll say 41.7. All right, so this is not technically our final answer. It says, how would you prepare 500 milliliters? So basically what you want to do is you want to take 500 milliliters, subtract 41.7, you get 458.3 milliliters. So how would you prepare this? You would take 458.3 milliliters of water and 41.7 milliliters of 3 molar NaCl. This is how that solution would be prepared. That's how you end up with 500 milliliters of a 0.25 molar solution. There you go. That's it. That's dilutions. That's the last calculation you're going to learn how to do in this unit. And that will pretty much wrap up solutions unit with the exception of pre-AP. All right. Thanks, guys. Y'all have a good one.